Hello guys and welcome back once again. So today we are back with after a long time with the Allen test series question papers. And guys, today's video is, I guess you have already seen, it's a bit long. So we are going to keep the videos long until and unless your JEE mains gets over. Maybe I will keep posting your 100-day series once again, and maybe I will speed that up also. And with regards to your mains, I will be posting really long videos from now on because I guess some practice is needed. Okay, so I hope you will all have the patience to watch them and obviously solve the questions. Anyways guys, I guess we will start off today. So this is the first question. So without any further ado, I will not stop to ask you to solve. If you want to solve any question, you can easily pause the video and do so. Otherwise, I will just keep on rapid firing. Okay. Okay. So starting off, guys, this is the first question. We have to find the sum of the series. So first thing that comes to your mind is we have to write the general formula of the Tn, right? So here Tn will be equals to, okay, one thing that some people might have a confusion about is that, like, you can see, right, the denominator for, say, if we consider the first term, the denominator is 1 factorial plus 2 factorial plus 3 factorial. So some people can do a mistake, like it's actually a mistake in this question. If you take 1 as, I guess, n, then your calculations will be a bit lengthy. Okay, so what I prefer is, don't take 1 as n, take 3 as n for the first term. Like if you keep reference of the first term, take the numerator as n, 3 as n, and therefore this will become n minus 2 factorial plus n minus 1 factorial plus n factorial. Okay. Okay, so this is the general term, and now we are going to simplify this a bit. So what I will do is, let's keep n like it is always present, and we can actually take n minus 2 factorial common out from this particular bracket. Okay, so what will happen is that n minus 2 factorial, this will become 1. Okay, n minus 2 factorial can be written as n minus 2 into n minus okay, wait. I told the exact opposite. N minus 1 factorial can be written as n minus 1 into n minus 2 factorial. So this will be n minus 1. And in a very similar fashion, this will be n into n minus 1. Okay. Okay, nice. So after this, we will take this thing and simplify. So this will become n by n minus 2 factorial, and here you can see n square minus n plus n will get cancelled, minus 1 plus 1 will get cancelled, so n minus 2 factorial n square. Okay, again 1 n also get cancelled, so this is becoming 1 by n into n, sorry, 1 by n minus 2 factorial into n. Okay. Okay, so right now we are going to do something. So this particular step might be a little tricky, so I guess I can explain that to you. So n minus 1 factorial can be actually written as n minus 1 into n minus 2 factorial, right? So we can actually write n minus 2 factorial as n minus 1 factorial divided by n minus 1. Okay, this is actually, like, there's a general formula for this. Anyways, we have derived it, and that is actually the best thing if you have low retentivity. So we can, like, if we want to convert n minus 2 in terms of n minus 1, we can write this as n minus 1 by n minus 1 factorial into n. Okay, now what is the, like, basic advantage of doing this is that we can once again take 1 by n minus 1 factorial common out, and that will give us 1, like n minus 1 by n, so 1 minus 1 by n, right? So you can actually write this thing as 1 by n minus 1 factorial minus of your 1 by n factorial. Okay, so basically you can see this is somewhat in the form of a telescopic now. That was the, like, prime motive for doing all this. This is the form that is the most convenient for solving this sum, because right now you can see that the sum that was given to us, which is sigma n equals 3 to 2008 1 by n minus 1 factorial minus 1 by n factorial. This can be easily solved. Successive terms will keep cancelling, and I guess what will be left over is 1 by 2 factorial, because after 1 by 2 factorial, like the next term will be minus 1 by 3 factorial, and in the second pair you will have plus 1 by 3 factorial. So if the second term from the first pair is getting cancelled, it means the terms that will remain will be the first term from the first pair and the second term from the last pair, or rather the last term from the last pair. So 1 by 2008 factorial. Okay, this is the minus, just see this. So I guess this is the like final answer for this question, guys. So this will be 2008 factorial minus of your 2. Like 2 factorial can be obviously written as 2, no issues. And this is 2 into 2008 factorial. Okay, this is the final answer. And I guess, guys, you can do the option matching. So I'm not waiting for that. I'm going on to the next question. Okay, so guys, moving on to the next question for today. So this will be the next question, and I guess this is like involving increasing decreasing functions, right? So maybe we have to draw the graph for this. So guys, I will not go in too much into a deep explanation. If you want an explanation, you can write down in the comments, but I guess that will not be really feasible right now for this question, because the graph drawing for this question is really easy. Okay, I have done it myself, and I guess it doesn't need much of a special explanation. Still, I will try to do as much as I can. So f of x is this. So next thing is we find out f dash x. So f dash x will come out to be in the same interval form as minus 55 when your x is less than minus 5. Okay, and 2x cube minus 3x square minus 120 on differentiating will give 6x square minus 6x. Okay, there's actually, guys, there is a printing mistake, I guess, which is 2. This thing is 2x cube minus 3x square minus 120x. Okay, this x is missing, just put that in. So 6x square minus 6x minus 120, which is your 6 into x square minus x minus 20. So if you factor that, I guess this will come out to be 6 into x minus 5 into x plus 4 when minus 5 less than x less than 4. Okay, and next on this is your 6 into x minus 3 into x plus 2 when x is greater than 4. Okay, this one I had already done, so rather I just wrote it down, so I guess you guys can do it. Okay, the differentiation is pretty easy. 6x square minus 6x minus 36, which is 6 into x square minus x minus 6, so basically minus 3 and plus 2, right? Okay, so next thing is we move on to the graph drawing for this, like the graph drawing for f of x using this f dash x, right? That's what we do. So if we draw, this is the y-axis roughly, this being the roughly x-axis, and as per the like critical points, I guess we can have minus 5 to plus 4 will work. So minus 5 minus 4 minus 3 minus 2 minus 1 0 1 2 3 and 4. Okay, so first thing is, guys, like observing your y is equal to minus 55x, y equals minus 55x. Okay, now this particular straight line is a straight line passing through the origin, but as you can understand, the straight line will be very highly steep, right? Because it's like 55, so it's very highly steep. So I guess that will come something around like this. Okay, and I'm stopping it here. Like my diagram is really bad because I'm drawing an approximate diagram. Okay, maybe if we extrapolate this thing, it will not even pass through the origin maybe, but don't go by that. We are only trying to find out the nature. Okay, so that's for y equals to minus 55x. Next on, if we see x minus 5, x plus 4, the critical points are x equal to 5 and minus 4. So basically, if we start moving from, I guess, minus 5, moving from your because like this particular curve, the second curve, which is 2x cube minus 3x square minus 120x, it was bounded in between minus 5 to 4. So checking from -5, we check first at -4 because that's one critical point, right? So -5 to -4, actually, if you check till -4, this thing is increasing. But after -4, this thing will fall sharply. And it will fall such that it directly passes through the origin, which is very evident because we have a factor of x, right? If we take the x common out. So this will directly pass through the origin, and passing through the origin, this will keep on decreasing like this until and unless it reaches 4. Okay, maybe I guess it will decrease after that also, but that's not our point of concern right now. Our point of concern is restricted till x equals to 4. Okay, so that's for -5 to 4. And when we go on for x greater than 4, this is the curve 6. Wait, the curve was, I will check once. Okay, 2x cube minus 3x square minus 36x minus 336, right? Okay, so x greater than 4, I guess there will be no issues actually. Because if we observe our f dash x at x greater than 4, it's perfectly increasing. So it will go on increasing like this. Okay, that's a very like approximate diagram, but that is our point of concern right now. So if you observe, the increasing intervals is what we had to find, right? So increasing interval x will belong to -5 comma -4 union 4 comma infinity. This will be the answer for this particular question. Okay guys, I hope this question is done. So now let's move on to the next one. Okay, so guys, here is the next question on screen, and this question is a fairly good question, I guess. So starting off directly, it is given that f is mapping from real to real is a twice differentiable function satisfying this given differential equation, and some values are given. So we have to find this inequality, like what are, I guess, a and b, and also we have to find out h of 0. Okay, so starting off, first thing is this is given as f double dash minus 5f dash plus of 6f is greater than equal to 0, right? Okay, now look at this thing. We can write this as, I'm segregating it. Okay, I'm writing this as f double dash minus 3f dash minus of 2f dash minus 6f. Okay, so we can rewrite this thing as f dash minus 3f whole dash minus of your f dash minus 3f. Okay, and this thing is multiplied by 2. So basically, if we move on, like, this inequality now becomes this particular thing is, I guess, greater than equals to 0, right? So I am going to do a very simple substitution here, and I guess you can all guess what it will be. I will put a y I will take, and this is equal to f dash minus 3f, and I will substitute this into this inequality. So basically this becomes y dash minus 2y is greater than equal to 0. Okay. Now after this, what I am going to do is I will multiply both sides with e power minus 2x. Or rather, if you don't understand it like this, you can write this as, say, what is y dash, right? So write this as dy by dx minus 2y is greater than equal to 0. Like, it's the integrating factor, basically, nothing else. Although this is really simple to solve, but I am multiplying it by e power minus 2x. Okay, so y into e power of minus 2x, I'm sorry, not y dash into e power minus 2x minus 2y into e power minus 2x will be greater than equal to 0. So you can actually understand that this thing is nothing but your y e power of minus 2x whole dash to be greater than equal to 0, right? So we can directly actually integrate both sides. We can integrate both sides to dx, and obviously this side is 0, so no heats about that. Therefore this thing will come out to be y e power minus 2x greater than equal to y of 0, right? The constant will come. Okay, so after this, like, we can do one thing, we can compute your y of 0. Okay, and one more thing guys, there is a limit actually. Okay, this thing is being integrated from 0 to x. Please keep that in mind. That is why y of 0 has come. Okay, some people will make a mistake. So we can find out y of 0 as f dash 0 minus of 3f of 0, which was like the expression we found out a while ago, right? So these values are, I guess, fortunately given. So this will come out to be 0 minus 3, which is equal to minus 3. So if you multiply both sides with e power 2x, this will come out to be y greater than equal to minus 3 e power 2x. Very fair. So now we have a perfect equation because we know what is y. We'll have f dash x minus of 3f of x to be greater than or equal to minus 3 e power of minus 2x. Okay, I'm sorry, not minus 2x, plus 2x. Okay, so like this is a like very good equation to solve right now. This is dy by dx, or rather if you want you can write df of x dx also if you want. I guess that would be better. df of x dx minus of 3f of x is greater than equal to minus 3 e power 2x. So either you can go with that thing, that is your linear differential equation, or rather I have a better method, and that method is we can actually multiply both sides with e power of minus 3x. Okay, now what is the need of doing that, you will understand. So basically if you multiply both sides with your e power of minus 3x, this thing will turn out to be f dash into e power minus 3x minus of your 3f e power minus 3x is greater than or equals to minus 3 e power of minus x. Okay, actually I did the LDE thing only, right? Because the integrating factor for this expression is itself e power minus 3x. Okay. I did the LDE solving only in a different way, okay? Like when you guys prove linear differential equation, I guess you know we have to do it like this. So it's the same thing round, okay? No issues. So moving forward, this thing can be now written very easily as your ddx of f e power minus 3x greater than equals to minus 3 e power of minus x. And if we integrate both sides now from 0 to x, so this is 0 to x dx, this thing will become f e power of minus 3x minus 1 greater than equals to minus 3 into 1 minus e power minus x. Okay, some people can get confused in this part, like why did you might think why did I avoid linear differential equations and all. So basically I didn't avoid linear differential equations. The like integrating factor that you guys find and put in the standard form, I have just multiplied that and done. Okay, it's nothing different, it's basically the exact same thing. So I guess no confusions here. Okay, so this is our f of like, I guess the equation is almost ready. So if we like multiply this, I guess minus 3 plus 3 e power of minus x, 1 plus 1 comes to this side. So f of x will be greater than equals to 3 e power 2x minus 2 e power 3x, or multiplying e power 3x to both sides. Okay, so this is your, I guess, the final inequality that we were talking about. So matching, this was given as AH of BX minus of BH of AX. So very fairly enough, H of X is e power x, A is 3 and B is 2, right? No confusions at all, I guess, can arise. So here you will have your A plus B into H of 0, I guess that was what was asked to us. So A plus B into H of 0 will come out to be equal to 3 plus 2 into 1. E power 0 is obviously 1. So final answer for this question will become 5. Okay, this was a good question, really good question. So guys, I hope this is solved. I will now proceed towards the next question. Okay, so moving forward with the next question, guys, you can see the question on screen, I guess. So I guess this is a multiple correct question. Okay, so guys, one thing, like I will be solving, I guess, some multiple correct answers in this video. So if you guys are revising it for JEE mains, I guess that should not be a problem, because after all you are solving the question, right? Multiple correct questions aren't involved in JEE mains. You only have numerical types and you have single correct. So anyways, I hope that will be a good practice for you. So moving on to this, here it is given that f of x is some big trigonometric expression. They have given a g of x, and we have to identify a few things regarding them. Okay, so first thing, we write down f of x once. It is given to be equal to cot x minus tan x minus of 2 tan 2x minus of 4 tan 4x minus of 8 cot 8x, and they have obviously given that x does not belong to n pi by 8. Very obvious, this should be given, right? So from here, like, I would like to improvise on one thing that I guess many of you should remember. Okay, basically, like, if people from class 11th are watching this will be very beneficial when you learn integrals in your class 12th. There's a formula: cot x minus tan x is equal to 2 cot 2x. Okay, this can be easily like derived, like 4 5 steps I guess, but I would advise you to by heart this. Okay, like if you are mains people, also do by heart this thing, because mains has used this multiple times. It came in my year's paper also and in previous years also. So I would like very much advise you to by heart this is really important. This is useful in your sums and in many integral problems which can't be solved normally. This works like a trump card. Okay, so they have given us that h of x is equal to f of x plus g of x, and obviously your g of x is x cube plus 6x minus 1. So if we move on to h of x, it is given as f of x plus g of x. Okay. Okay. So you guys might be thinking like, why am I reading out the question so many times? Because by now you should have understood that f of x is nothing but it is equal to 0. And the reason is because this formula. Okay, I will show you a little glimpse, I guess, just one step. You can write cot x minus tan x from this particular part as 2 cot 2x, and you can take 2 common and write 2 cot 2x minus tan 2x minus of 4 tan 4x minus of 8 cot 8x, right? So this thing will again turn into 4 cot 4x. Again you will take 4 common, cot 4x minus tan 4x. Again this will turn to 8 cot 8x, and 8 cot 8x minus 8 cot 8x will finally be 0. Okay. Like, I don't know if there is some other method to maybe solve this. There should be. But you saw, this particular formula just did your this complete thing like within a few seconds, right? If you remember this is just a matter of 5 seconds maybe. So that's the use. So basically h of x is nothing at all but x cube plus 6x minus 1, and it is such that the domain x is belonging to all real except for n pi by 8, where n is belonging to integers. So let's move on to the options, I guess. Now option number A is asking for h double dash x. So h dash x is given as 3x squared plus 6. H double dash x will be given as 6x, and therefore your h double dash pi by 24 will be given as pi by, I guess, 4. So checking on the options once. If we check on the options, I guess, yeah, your option number A is one correct option. Okay, next on they have asked whether h of x is an odd function. So moving on to your option number B, which says h of x is an odd function. Now h of x is x cube plus 6x minus 1. I guess no, h of x is not an odd function. So this function is not odd. So option number B, I guess, becomes wrong. In option number C, they have asked whether h of x is increasing or decreasing. So h dash x is 3x square plus 6. So whatever value of x you put, it will always be an increasing function. Going to option number D, we can check out, I guess, option number D once. It says if the equation h of x equal to lambda has a solution in 0 to 3, then the number of integral values of lambda is 7. Cool. So h of x is equal to lambda, and the domain is 0 to 3. So basically, h of x is x cube plus 6x minus 1 is equal to lambda. Okay, so moving back to the question, like A and C are the two correct options that we have right now. And if you read the statement h of x equal to lambda has a solution in 0 to 3, then the number of integral values of lambda is 7. Okay. So basically, this particular statement is wrong. It's not 7. This will be 44 values. Okay, I will explain. So basically, this is our equation x cube plus 6x minus 1 equal to lambda. And now they have said that this has a solution in 0 to 3. Okay. So our first thing is we have to first duty is to find out f of 0 and f of 3. So f of 0 is coming out to be, I guess, minus 1, and f of 3 will come out to be 3 3s are 9 3s are 27 plus 6 3s are 18 minus 1. So this is coming out to be 44. Right. So if we want a solution for like f of x equal to lambda, then lambda has to lie in between minus 1 to 44. Okay. So if we need to count like the number of integral values, I guess. So this will be, because it's an open interval, obviously minus 1 and 44 are not counted. So it's 0 to 43. So there's a total of like 44 values. That's why the total number of values here will be 44. Okay. It's not 7. Uh, don't know why they have given it as 7, maybe. It's like, obviously it's a wrong option. So why are we caring about? So D option is not correct, guys. Okay. So correct options for this question will be A and C. Okay. So guys, I am moving on to the next question. Okay, so moving forward with the next question, guys, and this question is a really interesting question. I like this. So they are telling that the number of possible ordered pairs x comma y is 2 for the system of equations given as your x y is equal to k and x power of p log y base 2 is equal to 2. Then which of the following options are correct? Like they have given different values of p and k and they are telling okay, not different values of p and k. P and k are all given to be 4 and they are telling us to find out the minimum integral value of k when p is given and the minimum positive integral value of p when k is given. Okay, so no fears. Like to solve this thing, the first thing that we are going to do is look at this one, because xy is equal to k is obviously its equation of a rectangular hyperbola, but this particular thing is not looking good. So we need to beautify this, I guess, a little bit. So for that I will be taking log on both sides. So p log y base 2 will come down and this is log x base 2, and very careful, I am taking log to the base 2. Okay, you have to be very careful of this. Some people will take log to the base e. I am not taking log to the base e, I am taking log to the base 2, and the reason you will get in a few seconds. And the RHS obviously becomes log 2 base 2, which is 1. Okay, so now what we do is we take p log y base 2, and from here y is equal to k by x. So I am putting this as p log k by x base 2 multiplied by log x base 2 as equal to 1. Now if we put, like if we let log x base 2 as equals to t, then we can transform this equation into p times log k base 2 minus log x base 2. So log k base 2 minus t multiplied by t equals to 1. Okay. So if we like do a little bit of manipulation in this particular expression, this will come out to be pt square minus log, I mean pt log, or rather p log k base 2 into t, and this thing is plus 1 equals to 0, and therefore this has turned now into a quadratic equation. Okay, so obviously for a quadratic equation to have two solutions, your discriminant delta or d, whatever you call it, has to be greater than 0. So p square, b square minus 4ac, so p square log k base 2 whole square minus of your 4p will be greater than 0. Now we will take cases here because we have been given different values of p and k, right? So in case number 1, if p is equals to 4, then you will see that if we put p equals to 4, I guess 4 4s are 16 and 4 4s are 16, so that will like cancel out with 0. So log k base 2 whole square minus 1 will be greater than 0. So that means log k base 2 plus 1 into log k base 2 minus 1 is greater than 0. So you will either have log k base 2 greater than 1, or you will have log k base 2 as less than minus 1, which means either you will have k greater than 2, or you will have 0 less than k less than half, right? That's the first case. Moving on to case number 2, which will tell us what happens if k is equals to 4. So if k is equal to 4, then this thing will turn into 4p square minus 4p is greater than 0, because it's log 4 base 2. So 4p into p minus 1 is greater than 0. So I guess you will automatically get this as p greater than 1 or p less than 0. Therefore, they have like asked us to find out the minimum integral value of, I guess, p. So minimum integral value of p will be equals to 2, because obviously p is greater than 1 and the next integer you will have is 2. Okay, so this is for p, and I forgot to write for k also. I guess they have also found, like, told us to find out the minimum integral value of k. Yeah, so for minimum integral value of k, because 0 less than k less than half, no integers here. So k greater than 2, which means we will have k equals to 3, right? And I guess that was your options. Yeah, no more options are there. So that's the question, guys. We have found out both the integral values, and I would be really happy if you match the options with yourself. Okay, so this question is done. Now I am moving on to the next question. Okay, so moving forward, guys, this is the next question on screen. So there is an inequality given, and we have to find out the number of integral values of x capital M, and some other obviously questions are also given regarding capital M. Okay. Okay. So looking at this particular inequality, the first thing that I can say is log root 5. I mean base root 5 and to the power 9 by 10 log 123 base 5 minus 2. This thing will be less than 0. Why? Because like first thing is the denominator can't be equal to 0. Second thing, if this particular fraction is less than equal to 0, it means that the denominator has to be less than 0, because the numerator is a square root which can't be negative. So from here, like, this is the first inequality, and another inequality that we get is your x minus 9 into 3 minus x. This has to be greater than or equal to 0. So from here, if we like flip the signs, I guess x minus 9 into x minus 3 will be less than equal to 0. So you get x belonging to like 3 to 9 closed. So you will get x as your 3, 4, 5, 6, 7, 8 and 9. So you get capital M as equal to 7. And if you add these, then I guess 4 plus 3 7 plus 5 12 plus 6 18 plus 7 25 plus 8 33 plus 9 is 42. So option number A is correct. And capital M is equal to 7, right? Okay. So moving forward, in option number B, they have, like, I guess the option number B and option number C inequalities are same. Yeah. It is mod x minus of 9 plus of mod x minus of 2 is equal to 7. So they have said that we need to find out the number of solutions to this. Okay, cool. So with regards to that, first thing that I will do is, like, this is something of the form mod A plus, like, if we take a form mod A plus mod B is equal to mod of A minus B. Okay, so guys, like, leave this thing. I have got another idea. That is basically the best thing is to draw the graph of this. Okay, will be a matter of like few seconds. I hope every one of you knows how to draw the graph of this thing. So if we take the y-axis and the x-axis like this, then the graph of this particular curve will be somewhat like this. This line will pass through, I guess it is 9 and 2, right? So this will pass through 0 comma 11. There will be a baseline, and there will be another line. Wait, my line is a bit crooked. Okay, this is actually a straight line. I hope you guys can understand. And there will be another line which is perfectly like this. And if you want to know the equations, okay, we actually don't need the equations. I will give you the points. This is your 2 comma 7, and this point is your 9 comma 7. Okay, we don't need the equations, we just needed these points because that is actually what has been asked to us. Now see, this is y is equal to mod x minus 9 plus mod x minus 2, whose graph of this is this one, and we have mod like y is equal to 7 as the other curve. Okay, so I will just change the color of my pen and draw the curve y equals to 7, which is obviously like maybe my reference axis here 7 is a bit close to the origin, but this is a rough diagram, so obviously you can cope with that. So y is equal to 7 will be a line that is horizontal and it will pass exactly like this. Okay, so this is the like curve, and this particular region where both these curves are intersecting will be the solution set. Now they have, I guess, in the options they have not given us like integral solutions or something. If they had given us integral solutions, then I guess if you look at this particular area there would be 7 integral solutions, but they have written only solutions, which means x belonging to real number. So that means that inside a line segment there are infinite real points, so obviously you will have infinite solutions for this one. Okay, I hope this is clear. So guys, moving on, like I guess option number B and C was this question, and obviously your option number A, after option number A, option number C will be correct. Okay, now moving on to option number D. Okay, so what does your option number D say? Option number D says log 7 base 5 log 7 base 2 is greater than 2. This is what I guess option number D is telling. Yeah. So if we try to estimate the values of log 7 base 5 and log 7 base 2. Okay, so basically we have to find out the validity of this statement, right? Whether this is true or like this is correct or this is wrong. So it's a very easy task. There is nothing to be like very afraid about. First thing we are going to do is log 7 base 5 will be obviously greater than log 5 base 5. Or in other words, log 7 base 5 will be greater than 1. Secondly, your log 7 base 2 will be greater than log 4 base 2. Or log 7 base 2 will be greater than 2. So this is one equation, this is another equation. You multiply both of them, and what you get is log 7 base 5 log 7 base 2 is greater than 2. So option number D also gets correct. Okay, I hope this question is done, guys. Like, good question for solving. So now I am proceeding to the next question. Okay, so moving on with the next question, guys. This question says a function f of x defined for x greater than minus 1 and has a continuous derivative if f satisfies f of 0 is equal to 1. I will write down f of 0 is equal to 1, f dash 0 is equal to 0, and there is an equation obviously given, which is your 1 plus f of x multiplied by f double dash x is equal to 1 plus x. Then they have asked some like facts about f of x, and we have to judge their validity, right? Okay, so first thing is first thing that you can notice from here is 1 plus f of x is equal to f double dash x is equal to 1 plus into f double dash x is equal to 1 plus x, and they have given us a very crucial piece of information, that is x is greater than minus 1. So if x is greater than minus 1, this particular RHS can never be negative. It is always greater than 0. It can't be negative, it can't be equal to 0, which means that your 1 plus f of x multiplied by f double dash x will also be greater than 0. So from here what we can infer is either 1 plus f of x is greater than 0 or f double dash x is greater than 0. Maybe either of them, maybe both, we don't know. Okay. So therefore from here f double dash x being greater than 0, we can infer that f of x is always concave, the first option. Because like judging the concavity, already it has satisfied one very crucial, like the first condition that we always check, and that is a continuous derivative, or rather the continuous function. So that is obviously given in the first statement, you can see obviously for yourself. Therefore I guess option number A will be correct. F of x is always concave. Moving on, in the next option, like they have said f of x less than 1 for x belongs to 0 to infinity and stuff. So I guess for that, we will now focus on solving the equation. Okay. So let's do one thing. I am writing f double dash x. Okay. Not solving the equation right now. Solving the equation will be actually important in option number C. Okay, let's do one thing. Instead of thinking too much, f double dash x is equal to 1 plus x by 1 plus f of x. Okay. So from here we can say that if your okay, guys, one thing that we can infer right now, like the minimum value of x that is permissible for our x greater than minus 1 is x equal to 0, right? So if you put f of 0 as 1 and if you put x as 0, you will understand that f double dash x is always greater than 1, no matter what. Okay, so guys, there was a misinterpretation in option number B. So I am doing it once again. Okay, this was a real mess. So option number B says that f of x will be less than 1 for x being greater than equal to 0, right? It was 0 to infinity, which means x is greater than equal to 0. Now we have to judge the validity of this statement. So basically this statement will be false. Now why? Because first thing that they have given us is that f of 0 is equal to 1, which you can well see here, I guess. F of 0 is equal to 1. And the second thing is that x equal to 0. Okay. Actually, x equal to 0 will have a minimum. I will prove that soon in option number D. I didn't solve the option sequentially. I am doing it for you guys sequentially, but I actually jumped onto option number D and then I solved it, then came back to option number B because that was easy for me to conclude. Okay. I will show you actually option number D will also be correct. X equal to 0 will have a minimum. Okay. This is the second thing. And for x is greater than 0, f of x will be greater than equal to 1. Okay. So on the basis of these three reasonings, we can actually say that this statement is false. And I hope that would need no more explanation because that's enough evidence I could provide. Okay. Going to option number C, where they have given us that the maximum value of f of 2 is 2. So our equation was given as 1 plus f of x into f double dash x is equal to 1 plus x. So guys, from here, like because we have found out that f of x is greater than equal to 1, if you apply this inequality here for f of x greater than equal to 1, you will find that f double dash x is greater than equal, okay, not greater than, f double dash x will actually be less than or equal to 1 plus x by 2. Okay, from f of x being greater than equal to 1. So from here, what I am doing is I will integrate both sides, f double dash x dx, and this will be integral 1 plus x by 2 dx, and both sides will be integrated from 0 to x and 0 to x. So this will be f dash x less than or equal to x by 2 plus x square by 4. Okay. So if we find out f dash 2, then it is coming out to be less than or equal to 2. So this is our like the thing we actually wanted. Guys, if you are reading that in option number C as maximum value of f of 2, It is not maximum value of f of 2, it is maximum value of f dash 2. Okay, the printing is really bad, so I just gave you a conclusion. So basically from here our option number C also comes out to be correct. So up till now option A and option C are correct, option B was wrong. And now let's move on to option number D, where I will actually tell you like why is this a local minimum, right? So going on to option number D, at x equal to 0, we have already, like, it is mentioned to us that f dash 0 is equal to 0. Okay, and if you see our functional relation, there it was given that f double dash x is equal to 1 plus x by 1 plus f dash x. I just brought the, like, okay, not 1 plus f dash, 1 plus f of x. I just brought this part to the denominator. Okay, so from this functional relation, you will understand that near x is equal to 0, the function, how should I explain this? Like, the function has a minimum value and it is initially very near to x equal to 0. It is trying to initially bend upwards from the minimum. Okay, something like this. Like if this is the minimum, it is trying to bend upwards something like this, very near to your x equal to 0. A rough, like, to make you understand, a rough representation. So from here only we can say that x equal to 0 is a local minimum. Okay. If you want, you can actually have another way of this. You can solve this further, and if when you get your f of x, you can actually, like, if you solve this further, integrate both sides as f of x less than equal to integral x by 2 plus x square by 4 dx, and then you find the constant and all. Obviously the information is given there also, like from there also, if you get the accurate f of x, from there also you can conclude that x equal to 0 is a local minimum. Okay, I had done that, but I am not going into it because there is a factor called time in your exam, and that is very important. Okay, especially if this type of a question comes as single correct in your mains, you have to do all the options, remember. Okay, which means your option number D also comes out to be correct. So correct options for this question are A, C and D. Maybe if it comes in your mains, you will get either of these. Anyways guys, I am moving on to the next question now. Okay, so guys, here is the next question, and to solve this, like, first we will look at the last statement that says the minimum number of solutions of f of x g double dash x plus of f dash x g dash x. Okay, so guys, what I am going to do is I will take this particular thing as your wait, okay, we will take this thing as some h dash x. Okay, so this will become h dash x is equal to, if you observe carefully, this thing is nothing but f of x into g dash x whole dash, right? So what we will do is we will integrate both sides to dx. So you will get your h of x as f of x into g dash x. Okay, now talking about the roots of h of x. First thing is, if we analyze your f of x and g of x individually as per the given values and as per the given information that both these functions are even differentiable functions in -2 to 2, the roots for f of x will be plus 1 by 4, plus half, minus half and minus 1 by 4. And in a very similar way, for g of x you will have 3 by 4 and minus 3 by 4. Okay, okay, and some more information is also given that is actually useful. First thing is, f of 1 is equal to 1 and g of 1 is equal to 2, which shows us that f of 1 is less than g of 1. So from here, if we are to find out the, like, number of roots for f of x into g dash x, number of roots for f of x is 4. Now for g dash x, now because g dash x has 2 roots, 3 by 4 and minus 3 by 4. So applying Rolle's theorem to g of x, we can say that g dash x will have, this is from Rolle's, okay, Rolle's theorem. So we can say that g dash x will have minimum 1 root. minimum one root. Okay. So from there we can say, because this thing has minimum one root and f of x has four roots, so we can say that your h of x will have five roots. So if h of x has five roots, applying Rolle's theorem to h of x, once again, if we apply Rolle's theorem to h of x, we obtain h dash x, and that is actually our target expression. So h dash x will have, according to Rolle's theorem, obviously, minimum of four roots. Okay. So the answer for this particular question becomes 4. I hope this was easy. Like, there can be, I guess, one more method to solve this, which is that if you express g of x, or rather if you express g dash x in terms of f of x or f dash x. Okay, I can give you a little glimpse. Wait, what we can actually do is, like, the concept will be very much same, but there will be a little bit of addition. So basically what we are going to do, guys, wait, if we try to actually okay, actually I spoke the very same thing that we did a while ago. If you try to express this in terms, it will actually come out to be the same thing. Okay, ignore this sum is done, and now I am proceeding towards the next question. Okay, so moving on to the next question, and this question is another really good question. Okay, so I am reading it out. Let f mapping from minus 5 comma 5 to 3 comma 18 be a surjective differentiable function, and g of x is equal to f of x into f dash x is twice differentiable function, given that g of 0 is equal to k. So then we have to find out the least integral value of k, such that there is always some c existing in between minus 5 to 5 for all functions to satisfy these given two conditions. Okay, this is the first condition and this is the second condition. That's the question. So this is a very good question, guys. I am proceeding with the solving. I hope you guys will pay attention. So first thing is, what we are going to do is we will apply LMVT. Okay, we are going to apply LMVT here, and I am taking some C1. I am taking a number C1 in between your. Okay, so guys, I am dividing this interval as minus 5, 5 and the midpoint 0. Okay, and now pay a little attention. Basically, I am taking C1, a number in between 0 and minus 5 for the time being. Okay, so applying LMVT in this interval, f dash C1 will be equal to f of 0 minus f of minus 5. I hope you know, right? If we apply LMVT in between a comma b, then it is f of b minus f of a whole divided by a minus b, which is 5. So this is your this thing. Okay, not a minus b. This is 0 minus of minus 5, b minus a. F of b minus f of a by b minus a. Okay, guys, I actually did a very bad mistake here. Don't take it in between minus 5 to 0. Okay, I was planning to like apply the mid, like take the mid range of this particular interval and do it. But don't do that. Don't restrict C1 to minus 5 to 0. Take C1 in between minus 5 to 5 itself. Okay, take it in between minus 5 to 5. Okay, so guys, the previous thing I did was a little messed up. So I like I suggest doing it once again, newly. Okay, let's do it fresh. So first thing is f is mapping from minus 5 comma 5 to 3 comma 18. Okay, that means that somewhere in between, like it is given, this is a surjective function. So what does it mean? Basically it means that somewhere in between minus 5 comma 5, f will be equal to 3 and f will be equal to 18. Now if you find out the distance between the endpoints, distance between endpoints I'm writing as ep, it is something that is less than or equal to 10. Okay, because it is, although it is a closed bracket, but I have to write it as less than equal to 10. I can't write less, or I can't write even equal to, I can't write less, I have to write both. That is the like point. Okay, So applying LMVT to f, like between the point where f equal to 3 and where f equal to 18. I hope you will remember this sign. This belongs sign such that mod f dash x is greater than or equal to 18 minus 3. Why 18 minus 3? Because that is this endpoint minus this endpoint. We are applying your, like the last one that I rubbed out, the C1 that I took, we are applying it in between minus 5 to 5. Okay, I have not written C1, I am directly writing x here. So f dash x will be greater than or equal to 18 minus 3 whole divided by 10, which is equal to 3 by 2. So at some point, the slope of f of x will be greater than or equal to 3 by 2, or maybe you can write this as 1.5 if you want. Okay, your choice. Okay, so this is done, and now next what we will do is we will apply LMVT to g of x is equal to f of x into f dash x. Okay, I'm trying to make things crystal clear. Like you will see that they have given us in the question two conditions on which we have to like evaluate all this. Okay, so I will even show you how these conditions are somewhat coming. Okay, so applying LMVT we have to find out, I guess, g dash x. So g dash x will be equal to f dash x whole square. Why? Because f of x differentiated as f dash x plus of your f of x into f double dash x. So LMVT tells us that there exists some c for which or such that g dash c is equal to 0, or in other words f dash c whole square is equals to minus f of c into f double dash c. Exactly the condition that was given to you. So first condition is automatically satisfied. Now for the second condition, if you notice your f, like I'm sorry, if you see f dash c whole square, and what you do is if you multiply both sides with of this particular equation, if you multiply both sides with f double dash c, then this will become f double dash c is equal to minus f of c into f double dash c whole square. Okay, and if you like if you consider the condition that for f of c is greater than 0, you will see this particular expression is always getting satisfied, right? So no restrictions from here also. That means both our conditions were absolutely true. So going on to, like, now we have to use your g of 0 is equal to k. If I move you back into the question once, you will see there was some stuff written that g of 0 is equal to k, and there exists some c belonging to minus 5 comma 5 for these two conditions to satisfy. So these two conditions are very well checked, and therefore g of 0 is equal to k, or I can imply from here that k is equal to f of 0 into f dash 0, right? So what is the, like, here we have to take the worst possible case. Okay, so worst possible case is maximum of f of 0, that is what, 18, and your minimum slope, the minimum slope, that is the minimum value of f dash x. Okay, this is very important. So okay, guys, sorry for the interruption. So value of f dash x, okay, minimum value of f dash x rather. So if you look here, we had yeah, here it is, we had found out that f dash x is greater than or equal to 3 by 2. Okay, now we are like searching for integer values, that is we are searching for if you see the question once, if you see the question once, we have been asked the least integral value of k. So if it was not mentioned least integral value, we could have taken 3 by 2. But because it is mentioned least integral value, we have to take not 3 by 2, we have to take the next value. Because f dash x is greater than equal to 3 by 2, right? So from there, we have to actually take it as 3. So your k minimum becomes 18 into 3. which is equal to 54. So your answer for this particular question becomes 54. Okay. I hope this question was clear. So now we move on to the next question. Okay. So moving on to the next question, guys. Here is the next question, and this is, I guess, will not be a very difficult question. So this is sigma r equals 1 to infinity 8 whole divided by 2r minus 1 root under 2r plus 3 into 2r plus 5, and this is a plus of your root under 2r plus 1 into 2r minus 1. And I guess there is one 2r plus 3 also given. Okay. Okay. And please be careful, this 2r plus 3 and 2r minus 1 are outside the respective roots. Okay. So the first thing that we are going to do is I will take this as sigma r equals 1 to infinity, and I am going to pull out root 2r minus 1 into 2r plus 3 from the denominator. So what is the use of that? We will pull out root 2r minus 1 into 2r plus 3. So this thing inside the bracket becomes 2r minus 1, 2r plus 5 under the root plus of root 2r plus 1, 2r plus 3 under the root. So very like that's a good thing, and this 8 also we pull out. Okay, so like you can consider this as we are dividing this into two fractions. This is one fraction and this is the other fraction. So sigma r equals to 1 to infinity. Now the real magic will happen, and that is basically 8 by root 2r minus 1 into 2r plus 3. And if you simplify, or rather if you rationalize the fraction inside, you will get this to be root under of 2r minus 1, okay, not 2r minus 1, 2r plus 1 into 2r plus 3 minus of your root 2r minus 1 into 2r plus 5, and this thing is whole divided by, this will come out to be, I guess, 4r square plus 8r plus 3 minus of 4r square plus 8r minus 5. Okay. So a little bit of calculation, but now this will like blend into something really good. This will become sigma r equals to 1 to infinity. And you will observe here that this denominator is becoming 8, 5 plus 3. So this denominator and this 8 are also cancelled. So directly this fraction by this fraction minus of this fraction by this fraction. Okay. So this becomes root under of 2r plus 1 by 2r minus 1. And minus of your root under 2r plus 5 by 2r plus 3, right? So if we like try to write down the respective terms, maybe because this is our tr, let's write down. So t1 is coming out to be root 3 minus of, I guess, root 7 by 5. T2 will come out to be your 2 to the 4 plus 1, 5 by 2 to the 4 minus 1, which is 5 by 3 minus root 9 by 7. Okay. T3 will come out to be root 7 by 5 minus of your root 11 by 7. Okay, that means a cancellation will actually happen. Let's move a little forward. T4 will come out to be root 9 by 7 minus of your root 13 by 7. Okay. And likewise, your Tn minus 1 will come out to be root 2n minus 1 by 2n minus 3 minus of root 2n plus 3 by 2n plus 1. And obviously Tn would come out to be your root under of 2n by 2n minus 1 minus of root 2n plus 5 by 2n plus 3. Okay. Okay. So like if we ignore these two also for the time being and look at the first four terms, you can see on summing up this and this are getting cancelled, which means after a while this term will also get cancelled, and after a while this term will also get cancelled. So your sum S, what will it come out to be? Basically this particular term would never get cancelled, so root 3 plus of root 5 by 3. And another term would also never get cancelled, which is 2. Okay, here after a while you will notice, I guess, wait, which term is it coming out to be 2? I guess that term will be root of 28 by 7. So that is coming out to be 2. Okay. So this is the final answer. Okay. So guys, this is coming out to be root 3 plus of your root 5 by 3 minus root 4. Okay. I hope this summation was clear. If this isn't clear, like some people might have a problem in sequencing this. So if you guys feel that I have a problem sequencing this, what you can do is you can apply limits at the last step. Okay. I haven't applied because it is pretty obvious. But if you want, you can apply limits at the last step and find that out. That is actually a better method. Okay. I have scarcity of time. I'm solving questions like you can see I have solved many questions today. So I'm not going into deep explanations. So that is why from here we will get your A as 1, B as I guess 5, and C we will get I guess as 4. Okay. Okay, this is not 1, this is 3. A3, B5 and C4. So A plus B plus C by 4. I guess that is what they had asked. I will check once. Yeah. A plus B plus C by 4. Yeah. So this will come out to be 3 plus 5 plus 1, which is 9. So your final answer for this particular question will become 9. Okay. So let's proceed on to the next question. Okay, so guys, here is the next question, and I guess this will be the final question for today. We have done a lot of questions. So this is like some p is given and we have to find out the minimum value of 1 by p. So not very difficult. First thing is p is equal to. Okay, what we are going to do is we will bring xyz to the denominator and divide all the terms. Okay, look carefully what I am doing. Okay, so this comes out to be 1 plus 5x, and xyz we will feed three terms like this. This will become 4 plus 3y by x. The next one will become 1 plus, sorry, not 1 plus, 5 plus 6z by y. And this term will become, I'm sorry, the line is a bit crooked. This one will become 1 plus 18 by z. Okay, and now what we are going to do is this 4, 5 are like not looking good. I want to make them 1. So I will make this 1 whole divided by 20 and multiplied by 1 plus 5x. After that you will have your 1 plus 3y by 4x. You will have 1 plus 6z by 5y and 1 plus 18 by z. Okay, so these are the terms, and after this what I am going to do is, this sum is almost done. Okay, I will take 5x as alpha, 3y by 4x as beta, and your 6z by 5y, let this be some gamma, and 18 by z as delta. Okay, so this thing will get converted into p is equal to 1 whole, okay wait, the line is crooked. P is equals to 1 whole divided by 20 into 1 plus alpha, 1 plus beta, 1 plus gamma, 1 plus delta. Okay, okay, so 1 plus alpha into 1 plus beta into 1 plus gamma into 1 plus delta, everybody knows what this will be, right? This is equal to 1 plus sigma alpha plus of your, I will take the screen a bit downwards. This is 1 plus sigma alpha plus sigma alpha beta plus of your sigma alpha beta gamma plus sigma alpha beta gamma. Okay, I guess that's done. This is not sigma alpha beta gamma delta. This is only one term, alpha beta gamma delta. Okay, so that's it. Okay, So guys, this like now from this part it is pretty evident that this particular bracketed expression will come to be greater than equal to 256. Okay, from AMGM. I'm not going into that, pretty easy. So this is greater than equal to 256 and therefore P is equals to 1 by 20 into 256, right? And if we look into the question, I guess we were supposed to find out the minimum value of 1 by P. So that will come out to be 1 by P is equal to 5120. Okay. So I guess guys this will be the end for today's video. I will bring out more questions because there are lots there to solve. So I will bring out more questions in the next videos. So if you have liked my channel, to like, share and subscribe. Anything you want to ask, always welcome in the comment section. And also to join my Telegram discussion chat for good discussions on your JE prep. And that's it for today guys. And thanks for watching and Happy New Year.